Okay, we need to figure out a unit vector that's perpendicular to both of these. So that's why we're going to do the the vector product, so A cross B, and we set it up like this, where 3, -1, 2, we write them sideways in the I, j, k components, and then 1, 0, -1. So then we find the first determinant. We want to ignore the I columns, so we write down -1, 2, and 0, -1. Find the determinant of that matrix. So if you have a matrix A, B, C, D, the determinant would be AD minus BC. So we do -1 times -1 minus 0 times 2. So we get 1 minus 0, which is 1. So that's our I component, 1I. And then we always do the opposite sign of the J. So the J matrix would be 3, 2, 1, -1, because we're ignoring the J column now. And then we do 3 times -1 minus 2 times 1. So that's -3 minus 2, which is -5. But now I do the opposite sign of that, and I get 5 for my J component. And now we do the K. So we ignore the K column. We do 3, -1, 1, 0. So we do 3 times 0 minus 1 times -1. So that's 0 plus 1, right? Because 1 times -1 is -1, and then we're subtracting that. So we get 1K. So our vector is I plus 5J plus K, but this won't have a length of 1. A unit vector means the magnitude is equal to 1. So we need to find the magnitude of this vector. 1 squared plus 5 squared plus 1 squared, which is 1 plus 25 plus 1. And multiply by 1 over the square root of 27. This will now have a length of 1, and this vector will be perpendicular to the two vectors that we were given.